Good morning. My name is Michael Gamboa, and in this video, I am going to explain a simple way I use that we can give to the SolidWorks program in relation to force simulation. Okay, we start, open the program. Okay, we can see from the example that the program gives use. It is a basketball hoop. Okay, it's this figure to which the balls are configured, and then a force is simulated to measure the resistance of the material and the bolts. Okay. In this part, only can see the figure, so we open the tab name it ready. Okay, in this part we can see the bolts are configured. In this part are 4 in total. We can see the force it's applied. It's a 250 libras. Okay, in the left we can observe the connection. In specifically, the connectors are bolt connector 1, connector 2, 3, and 4. We can observe in the piece the number. Okay, and here we can observe the local interactions are set the contact 1. In this part, we can see what part are talking about. It's in color blue. In this part, we can see the force. It's force we are configured for the simulation. Okay, and this part we give the results. In this part, we can see an stress applied on basketball hoop. We can check its majority, it's in color blue. And in this part, we can change to displacement 1. And the color change, okay, into force are applied. The color change to red, and from here is yellow, green, and come back to blue in this part. The most important of this video is the results of the bolts stress, and we can check this in this part in results and list connector force. In this part, we can check one per one a bolt connector and the resultant force. The most interesting part of the program SolidWorks is we can check a bolt connector individually, and we can check the shear force are 553 and the axial force 1567, and the torque it's 0. We can check The connector 2, the shear force increased to 800. The axial force the same in increase, incrementa. And this part we can check the ball connector 3 and the ball connector force. We can observe in this part what connector we are talking about. Okay? And in conclusion, with the realization of the example, it was possible to know a new function of the program, very useful for the calculation of the force of the piece and that we are going to carry out. It is important to understand that behind the simulation, it is necessary to carry out a previously calculation to determine the type of material and the necessary bolts. For this particular case, the structure and the bolts used correctly support the applied force. Thanks.